Okay, this is question 10 on the Edexcel specimen paper for A-level statistics, and if you've got it in front of you, I think I might let you read it. You can see it is people running 1 mile in under 4 minutes in 1954, and it's going up in the years, and they've plotted out some lovely things here. And then they're asking you to calculate the equation using the data given in figure 1 that they can be used to predict the actual world record times. So, finding your stats menu and trying not to block myself with what I've got. So it's your choice. I think potentially we could put in the actual numbers. So I'm going to put in 1955. 1960, 1965, 1970, 1975, 1980, 1985, 1990, 1995, 2000. So then it means I can just put in the year. I don't need to think about trying to adjust it, because I could have put 1, 2, 3, 4, 5. And that will work as well. It doesn't really matter. But I'm going to leave it as the years, because it's the data that's there, and it means I can just put in any year that I'm interested in between those values without having to make any adjustments. Now hopefully if that's in right, I'm going to graph it first, because I like to see what the graph looks like. That's not very useful. Oh, there it is over there, is it? Video, V window. I've been having a problem. Graph. I think that's going to be too small now. That's still not going to help, I would imagine. Zoom, that's what I want. Zoom. There used to be an auto. Oh, it's really not plotting, is it? Not finding it for me. Okay, so that's not very helpful. However, that's the answer I get. So it's y equals ax plus b, so y equals minus 0.3117575x plus 636.380606. Now hopefully you will get your calculator showing you a proper image before we go any further, so that would be really annoying. And then it says blah, 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 2010. So these are all in May, so that's good, so I can do this. So if I just make x equals 2010 and put that in, minus 0.311757 times 2010 plus 636.380606, and this should be my answer. Back to the calculator, minus 0.311757 times 10 plus 636.380606. So I've got 9.749036. Now the time was measured in seconds, but in excess of that. So my actual time will be, that's 9 seconds onto, so it's 3 minutes 39.7 seconds approximately. Would be a good answer. Is that a reliable prediction? Well, is it valid? There is extrapolation because it's outside the range of data. So we could say it's unreliable. But having said that, we could say it's only just outside the range. And the plot that we're seeing does look like there's a very clear correlation between the two. So we could say it's reliable. So you get a mark here for saying either it's unreliable or it's reliable. Your choice. Okay, next point. The equation is used to predict the record time of running 1 mile in May 2020. In fact, as March 2016, the world record time for running 1 mile has not been broken since 2099. How could we use this information for the prediction of 2020? Well, the record time has remained at the same rate, and the rate of decreasing times has levelled off. So we could either say that potentially it's going to be the same as it was there because nothing's changed, Or the prediction from the model is probably going to be too low, because if we use that model and keep going down, it's going to be very low for 2020. So I would suggest that extrapolation at this point would make it, the information for the prediction of 2020 wouldn't be very good. The total value of the government investment into athletics during the previous 12 months was also recorded on the same 10 dates as those in Figure 1. It was observed that the value of Y increased each time. State the Pearson's rank correlation coefficient for the 10 pairs. Well, from looking at it, and if you're not sure, this is what you've got to do. So if we rank them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because they were in order, and we rank this, maybe we can't do that. So they say it's increased in terms of the value increases each time. Well, so the time goes down, the values increase, we'll have a -1, a perfect negative correlation. That's a nice, easy question if I read it properly. And then finally, using this information, a newspaper reported under the headline, "More investment needed so our athletes complete the world record. Give 2 reasons to doubt the validity of this statement." Well, there is a correlation, but it doesn't mean that more money means a faster time. So it's the whole thing of correlation does not imply causation. So we're not, definitely, that doesn't mean that that's actually happening. There is a correlation, but it doesn't mean that that's what you do that and that's your response. The data only refers to 1 mile runners, not all athletes. Well, and we're also not considering inflation, and newspaper reporting can be unreliable. So I think the one I like the most for this one is data only refers to 1 mile runners. So it's our athletes, they're talking about all of the athletes, not all athletes. Okay, that would be good.